Hi friends, I am your Abhiram. Hope you all are doing good. So in this session, we are going to discuss about irrational numbers. Let me write it, irrational numbers. Irrational numbers. So the name suggests that irrational. That means it is quite opposite to rational numbers. So let me tell the definition of irrational numbers. Let me tell you that. So irrational numbers are the numbers which cannot be written in the form of p by q, where p and q are co-prime integers and q is not equal to 0. Let me write it. Irrational numbers are the numbers which cannot be written in the form of p by q, where q is not equal to 0 and p and q are co-prime integers. Let me tell you again. Irrational numbers are the type of numbers which cannot be written in the form of p by q, where p and q are co-prime integers and q is not equal to 0. I hope you have understood the definition of irrational numbers. So let us go into the next topic, that is the decimal expansion of irrational numbers. The decimal expansion, like if irrational numbers are written in the form of any decimal or decimal expansion or decimal form, then the type of decimal expansion is called as non-terminating, non-recurring or repeating, non-recurring or non-repeating. Let me write it. The decimal expansion is called as non-terminating and non-recurring. Irrational numbers decimal expansion is called as non-terminating and non-recurring. Here terminating means finite decimal places after the decimal point. Here it is non-terminating, that means infinite. It's not terminating, that means it is infinite decimal places after the decimal point. Recurring or repeating means a group of numbers repeating again and again after the decimal point. But here it is non-recurring, that means it does not repeat again and again after the decimal point. So I hope you have understood the definition of irrational numbers and the decimal expansion of irrational numbers. Let us go into the next topic. Let me tell you about the next topic, that is about non-terminating, non-recurring decimal expansion. Let me write it. Non-terminating and non-recurring. I have told you about this, but I will give you a proper definition for this. So, non-terminating, non-recurring is a decimal number which continues endlessly and do not have any group of numbers repeating again and again after the decimal point. Let me write it. It is a decimal number which continues endlessly and do not have any group of numbers repeating after the decimal point. So this is the definition of non-terminating and non-recurring decimal expansion. It is a decimal number which continues endlessly and do not have any group of numbers repeating after the decimal point. Let me give you an example for this. That is 0.12 112 312 and 11112. That is 4 times 1. Okay, so this is 1 actually. The example is 0.12 112 312 11112. So this also satisfies non-terminating and non-recurring decimal expansion and also irrational number, because the decimal expansion of irrational number is what? That is none other than non-terminating and non-recurring decimal expansion. So this satisfies this decimal expansion and also irrational number. Let us go into the next topic, which is very interesting. Let me tell you the last topic, which is very interesting, that is where the irrational numbers are used. Irrational numbers are used in You may tell that what are the uses of irrational numbers? We don't know anything. Is there any uses of irrational number? Yes, there are several uses of irrational numbers. Let me list out all the uses of irrational numbers. The first one is it is used to find the length of the diagonal. Length of the diagonal of a square when the sides are given. Sides are given. Let me explain you this. Length of the diagonal of a square where sides are given. Let me assume that this square, actually this is a square. Let us assume that all the sides are 5. One side is 5 actually. In a square all the sides are equal, so all the sides are 5. Now, they are telling that irrational numbers are used in finding the diagonal of the square when the sides are given. What is the side here? It is 5. and we can find what it is the diagonal of the square. That is the first use of irrational numbers. Second use. What is the second use is nothing but finding the hypotenuse. Hypotenuse of a right angle triangle. We know about triangle and also right angle triangle, and also we also know about the hypotenuse, which we have studied in our previous grades. Let me tell you again. This is the right angle triangle where there is 90 degrees found here, and the largest side is called as the hypotenuse, and this is the hypotenuse because it is the largest side. Hypotenuse. So this statement suggests that irrational numbers are used in finding the hypotenuse of a right angle triangle, that is this side. This side is the largest side, which is called as the hypotenuse, and irrational numbers are used in finding this hypotenuse of a right angle triangle. Let me tell you the last use of irrational number, that is, it is used in deducing. Reducing the circumference of a circle where the radius is known. The third use is nothing but it is irrational numbers are used in deducing the circumference of a circle where the radius is known. Let me tell you it again. This is a circle and this is the center of the circle. Let me draw the radius. Here they are telling that deducing the circumference of a circle where the radius is known. What is meant by circumference? This is called as the circumference, the outer layer of the circle. This is called as the circumference. Let me write it. Circumference. This is called as the circumference and this is the radius, small r. And he is telling that deducing the circumference of a circle where the radius is known. Radius, let us think that radius is 4. If the radius is known, then we can find the circumference by using irrational numbers. These are the 3 uses in which irrational numbers are used in finding the length of the diagonal of a square and hypotenuse of a right angle triangle and the circumference of the circle. So the first one is square and the second one is right angle triangle and the third one is circle. I hope you have understood all the topics that have discussed in this video or episode. I will meet you in the next episode. Bye bye.